Okay, we know natural climate solutions or nature-based climate solutions basically mean that we are using natural processes like agriculture. Well, I don't know if it's natural, it's human activity, but can we use that to sequester additional carbon? So use methods that actually reduce emissions, enhance sinks, and so on. So here is a nice paper that talks about, sorry about that, priority science can accelerate agroforestry as a natural climate solution. We've talked about agroforestry before, but this is a nice paper that makes some additional points I'm going to run through. Not sure if I'll finish it in one podcast, but doesn't matter. The expansion of agroforestry could provide substantial climate change mitigation up to 0.31 petagram carbon per year. This is an estimate. If, under ideal conditions, this is the potential. And remember, right now we are about 10 petagram carbon per year in terms of total emissions, comparable to other prominent natural climate solutions such as reforestation, and there are lots of discussions to be had about that. Yet climate-focused agroforestry efforts grapple with ambiguity about which agroforestry actions provide mitigation, uncertainty about the magnitude of that mitigation, and inability to reliably track progress. So if you pay a farmer to do agroforestry and say, show me how much additional carbon you sequestered, that means you would have done something, let's say planting trees in your farm that sequesters some carbon, but you are putting in more trees, you are following agroforestry methods carefully for long enough time to show that you're putting in more carbon than just doing farming and something like that. So additionality is one of the constraints that always is used as a way to decide how much to pay someone for these so-called clean development mechanisms, if this process still exists under the UNFCCC or not clear. So in this perspective, we define agroforestry as a natural climate solution, discuss current understanding of the controls on farm scale mitigation potential, and highlight recent innovation on emergent high resolution remote sensing methods to enable detection, measurement, and monitoring. We also assess the status of agroforestry in the context of global climate ambitions, highlighting regions of underappreciated expansion opportunity and identifying priorities for policy and praxis, which is of course implementing in practice. But if we want to be sure about the formal definition, we can say here, what is praxis? And now AI answer shows up first, which is a new thing from Google. Praxis is a process of putting a theory, skill, or lesson into practice. It can also refer to the act of applying, exercising, or practicing ideas. So agroforestry, the incorporation and maintenance of trees in agricultural landscapes, is a broad term encompassing a diversity of indigenous, traditional, and modern farming practices. Lots of explanations, and you can think about this also as natural climate solutions, because from a climate change perspective, a key benefit of agroforestry is to increase or protect carbon storage on agricultural land. So we can do this without reducing food and fiber production or eroding biodiversity. There are additional advantages of increasing soil carbon, soil nutrient uptake, soil moisture retention, groundwater recharge, increasing crop yields, and so on and so forth. So you always want to understand, if ideally you looked across the world and said everybody started doing agroforestry, what is the potential for additional carbon sequestration? Okay. So here the idea is to answer 4 key questions. What is agroforestry natural climate solutions? How well do we understand its mitigation potential, and how can that be improved? The mitigation potential. How can agroforestry locations and practices be mapped, and how can its extent and carbon density be monitored? What other information and incentives will be best will best support agroforestry adoption and expansion. Just because it's a good idea, it's a mitigation potential, and it's a natural climate solution, doesn't mean every farmer is going to go and do it. So you need to incentivize it somehow. Paying them for this additional carbon sequestration is one way, which was what was already approved under even FCCC as clean development mechanism. Lots of countries in Africa did it. I think Asia also got paid. China for sure did, and so on. So defining agroforestry as a natural climate solution. Agroforestry is a land use, obviously, typically defined on the basis of management practices, species composition, or other agroecological characteristics. By contrast, an NCS is a land use change defined by the ability to mitigate climate change without decreasing food security or biodiversity. So there are subtle differences. So agroforestry natural climate solution is then defined as the intentional establishment, increase, or maintenance of trees in agricultural landscapes, providing additional net carbon storage against a business as usual baseline without causing net reduction of current food and fiber production or negative impacts on biodiversity. Very formal definition, and if practiced appropriately, that's exactly what it should do. Okay, so here is a schematic infographic, you can say. No existing agroforestry, so baseline has to be established if you want to track land use change and carbon outcomes of whether agroforestry is a natural climate solution or not. So you look at a land where the agroforestry didn't exist, and then you adopt it. So if trees are removed from forest or woodland, then it's not a natural climate solution to do agriculture. Whereas if you are doing farming and you added trees, there are ways in which you do it. Trees established on agricultural or degraded land will make it a natural climate solution. Here you can also have trees established on non-forest native habitat, so you are going to change the biodiversity, let's say, including the animals and birds and other insects, everybody that relies on that natural biodiversity. So you're changing land use to move towards agriculture, and you're putting some trees, but you have changed land in a way that is not natural, right? So if there is an existing agroforestry, then management change, where you again take forests and introduce agriculture in the middle, then that's not a natural climate solution. Or if tree cover decreased in rotational agroforestry system overall, then that's not a natural climate solution either. But schematically speaking, if you increase the tree cover on an existing farming site with trees, then tree biomass is increased and static agroforestry system is established. Here tree biomass is decreased, or the tree cover decreased in rotational agroforestry, as we said. Or you can also increase tree cover in rotational agroforestry. So this is a way to incentivize. If you are doing this, and if you want to move towards this, you can be paid for additional carbon sequestration and qualify as natural climate solution. Of course, the risk of removal, where you remove existing trees, then you are obviously not in a natural climate solution by definition. Whereas if you conserved trees in at-risk agroforestry systems, so you have to understand, you have to define a risk, and it looks like you reduced the tree cover, but you increased crop yields, let's say, or at least maintained carbon, and you maintained biodiversity, food production, and fiber production, and so on and so forth. So you get the idea that these are schematic ideas. They have a methodology for estimating mitigation potential of agroforestry. In the past decade alone, there have been more than 20 synthetic studies quantifying agroforestry carbon stocks and fluxes. These efforts have primarily focused on carbon in above ground and below ground woody biomass. So above ground above ground biomass and below ground biomass, and on soil organic carbon, and they consistently demonstrate substantial mitigation potential. This is known for a long time, and you can imagine that when we went from hunter-gatherers and started becoming agriculturalists, we had naturally done agroforestry because we were not large in population, we were not wiping out forests to increase production and so on. However, carbon estimates vary widely across these studies, indicating a knowledge gap about the controls on farm scale carbon sequestration and storage. This makes it challenging to accurately estimate mitigation potential at existing agroforestry natural climate solution sites, because direct measurement is often cost prohibitive, and at potential sites under consideration is also a challenge, because you want everybody to do agroforestry, you want them to do additional carbon sequestration, you want to monitor, but it's not so easy to monitor soil carbon and prove additionality. So you have to find, satellites could potentially be used, but soil carbon is not just the surface quantity, and so on and so forth. So carbon stock changes after agroforestry adoption vary within and across practices. So change in above ground carbon or soil organic carbon density in milligram carbon per hectare is shown with intercropping, fallow, so you do agriculture during a season and let's say let the land lie fallow, silverable, so silvo-arable, so you are using trees and agriculture, and silvopasture where you are doing trees and grazing, and multistrata, you have terraced farming with agroforestry and so on. So you can see that the changes can be larger in the multistrata, silvopasture, large tail, but the maximum is over here. Silvo-arable shifted, but also tail is smaller, and intercropping has the smallest change in carbon. Okay, so mapping and monitoring agroforestry, of course, knowledge of where agroforestry occurs and how much carbon it stores is foundational to many of the scientific needs underlying AFNCS implementation efforts. These include improved estimates of mitigation potential and expansion potential, and establishment of baseline tree cover extents and loss rates for monitoring, reporting, and verification. However, current understanding of the spatial distribution of agroforestry is weak, so baseline is needed of what's happening now, with estimates of the global agroforestry now varying fourfold from 400 million hectares to 700 million hectares to 895 million hectares based on which reference you use, and even 1600 million hectares. So you get the idea. So the structure variety of agroforestry systems, including both scattered trees outside forests and trees within agricultural forests, complicates mapping methodologies and can introduce bias, but basically you will need drones or satellites and so on to cover large enough area to do this, and monitoring with personnel involved is going to be very tricky. Nonetheless, global comparisons between remote sensing of agroforestry and site locations gathered from literature, so a meta study, shows that the percentage of overlap can be relatively low in terms of woody carbon density in milligrams, megagrams carbon per hectare. Okay, so just the idea is to look at globally how you can do site locations gathered from literature, where local studies estimate these woody carbon densities and report them, and then you use satellites or drones and see that the overlaps are there, but the differences can be large. Sorry, my throat is really today feeling a little froggy. This is the importance of spatial precision, spatial resolution, and temporal dynamics in remote sensing of agroforestry. Obviously, you want to track it over time for additional carbon sequestration because trees take time to grow, and if you start planting and then over time you have to monitor it, and there are different satellites here: Landsat, Sentinel, Planet, and CNE Airbus. I won't go into the details, but you can see that tree cover increased over here at monitored sites and then dropped off and then increased again. So 2014, 15, 16 were El Ninos as well. So you have to see what are human activities, what are natural degradation of forest covers or trees, and so on and so forth, but precision obviously matters. So the potential and implications of agroforestry expansion to help motivate and spatially prioritize investment, multiple studies have estimated or mapped the global mitigation potential of AFNCS. These efforts have focused on modeling locations where agroforestry is biophysically possible with soil quality, water, etc. Only sometimes they add constraints to maintaining crop yields to ensure cost effectiveness. These results aggregated to the globe suggest that cost effective potential is as high as 1.12 per gram CO2 per year, not carbon, placing agroforestry among the most promising NCSs. So 1.12 per gram CO2 compared to what we are emitting somewhere around 30 to 40, and if you do CO2 equivalent, it will be higher. Plus, you have to see whether how effectively they can contribute to staying under 2 degrees C warming by 2100 and so on and so forth. So regardless of improvement in policy frameworks, the future of AFNCS on the ground ultimately hinges on the decisions of many individual farmers and ranchers to adopt or maintain agroforestry. So it's not like you planted trees, got paid, and then you didn't take care of the trees. You have to maintain agroforestry. This in turn depends on local decision-making contexts that enable and incentivize agroforestry and minimize barriers. Governments and non-state actors wishing to promote AFNCS must continue developing research, policies, and programs to address the various barriers and enablers, including land tenure rights and security, access to technical knowledge and training, credit access and short-term funding, market development and access, and of course market failures and misaligned incentives. You don't want maladaptation or incentivize wrong things. From an NCS perspective, the fact that agroforestry climate mitigation is predominantly a public benefit rather than a private benefit to the farmer creates a market failure that can serve as a major barrier. Carbon markets and other payment schemes can help rectify this, transmuting public benefits into private ones. So you have to incentivize farmers who are taking a risk with agroforestry, especially as agricultural MRV protocols mature, monitoring, reporting, verification. However, many of the other potential agroforestry benefits may accrue to farmers directly and thus more directly influence their decisions, like increased soil carbon should give them increasing crop yields or at least not degrade soil health and crop yields. But these are long-term benefits, and knowing those as opposed to what would have happened without agroforestry is not so easy. Farmers, have to be just motivated to do it, but incentivized to do it as well. Enthusiasm about the many potential benefits of AFNCS is justified, but must be paired with recognition that the actual outcomes of agroforestry adoption are complex and context dependent and can impose important trade-offs. Realistic knowledge of outcomes is frequently lacking, but mechanistic modeling, meta-analysis, and local co-development of applied research will play important roles in generating the knowledge needed to inform farmers' decisions about whether and how to adopt agroforestry. Farmers' mental models are complicated. They're always dealing with risks, and you go and tell them to do more things, then you have to really convince them. And in India, when families become nuclearized with inheritance becoming smaller and smaller in terms of the land you own, putting tree on a little piece of land seems kind of not very attractive to farmers. But Can you have a community level agroforestry that tells them everybody will benefit by reduced evaporative loss and non-rainy season income from the trees like fodder and other things, and so on and so forth. So it's a complicated socio-economic problem as well, but we always keep a tunnel vision on carbon and mitigation, which can work if we incentivize them that they can benefit from it. So finally, this is the woody carbon density, various variations in current and potential additional agroforestry carbon storage. I won't read all of these details, but this is showing Africa, North America, Asia, Oceania, Central and South America, Europe, and basically you see that the Human Development Index versus the log of the average carbon density is negative. So if you reduce carbon density, then what does it mean here? Sorry, let's read carefully. Countries year 2000 log transformed average agricultural woody carbon density versus the year 2000 Human Development Index. While the relationship varies across continents, the overall relationship is negative and significant. With the trend, the countries are color coded by continents, styled by weather or not. They mention agroforestry in their nationally determined contributions and sized by modeled cumulative AFNCS mitigation potential by 2050. Countries in the 95th percentile of cumulative mitigation potential are labeled black, and so on and so forth. Essentially, there is a relation to HDI, but attribution becomes very difficult. If you say if you cut down forests, your overall development index, quality of life, standard of living goes down, you have to convince people to then go back and put trees and wait for the trees to recover the loss in HDI and so on. So finally, decades of research demonstrate agroforestry's potential to help mitigate climate change while also improving agricultural livelihoods and sustainability. However, an extensive and prioritized scientific effort is needed to transition AFNCS from potential to practice, synthesizing existing knowledge to elucidate the factors driving the climate outcomes of agroforestry actions is a first critical step. Simultaneously, improved reporting of carbon stocks and covariates can help further reduce the uncertainty of mitigation estimates. Improvements in remote sensing methods and in the quality and quantity of spatial data will enhance agroforestry mapping abilities, opening opportunities to develop more rigorous, replicable, and consistent MRV protocols. Finally, the successful expansion of AFNCS will depend on an outsized decentralized effort to incentivize agroforestry investment and remove barriers, not only in developing nations but also across all suitable agricultural lands. Agroforestry's greatest strength is its multifunctionality. Agroforestry not only has the potential to provide climate change mitigation, the focus of this perspective, but also can play a crucial role in a holistic systemic response to climate change, supporting adaptation and enhancing the resilience of the global food system while improving rural livelihoods. So I mentioned the fractioning of the land or fracturing of agricultural land in India or poor countries, but in the US on the other hand you can have huge tracts of agriculture with industrial production. Agroforestry is even important there. How will you convince a rich farmer who is happily doing tractor-based precision agriculture, smart agriculture, drone monitoring, this and that he should put trees in the middle, right? So it's not an easy task. So it has potential and it has challenges, it has barriers, it needs investment and incentivization, but it's a good idea. So hopefully it will grow into implementation. Okay, see you in the next topic.